represent something. Okay? So variables are letters. Oops, I won't write in cursive. I've heard that some of you can't read it, so I apologize. A variable represents numbers or a number, depending upon how many variables you're given. Okay? So a variable would be x, or a variable might be xy, in which case two numbers are being represented. And by the way, there isn't a always x is 12 or always y is something. You're not memorizing a set of numbers that matches a particular letter. These are just items that represent something that you're going to solve. Okay? Variable expressions, and I'm going to shorten it a little bit. Make sure you're copying along with me, okay? Because there's a lot of material. A variable expression is when we use letters and numbers operators, which is plus, minus, multiply, divide, and an equal sign, less than, greater than, and that kind of stuff. Okay? For example, x plus 6 is 7. Is there anybody that can guess what the value of x is in this here situation? Wow, everybody can. Okay, Isabella, go. She's right. She's right. X just so happens to equal 1 here. That's not in your book. By the way, what I have just done leads me to my next scenario, or my next word, which is evaluate. I have just evaluated and solved it to the best of my abilities. They talked about the whale, and I'm going to get into the whale here in a minute. They told us in the little story that whales eat 4 tons, is that per day? If I remember correctly, 4 tons per day. Okay, super. So depending upon the amount of days that our whale is eating, that's how much tonnage we have to look for. In example 1, they say, evaluate the expression 4 times d. A dot means multiply, just like x means multiply, just like letter next to number means multiply. All of these things indicate the operator multiply. Okay? Whales eat 4 tons per day. Evaluate when D equals 120. So that's 120 days, right? If D equals 120, and I plug in 120 in any of these multiplication scenarios, I will find out how much food our friend the whale eats. And they've already shown you it is 480, right? The D value they gave us is 120 days. What if I just want to know how much he eats in the month of September? How much will he eat in the month of September? September happens to have 30 days in it. And that's 120 pounds. So based on what you're given, you use letters to represent a given scenario. This letter, this representation right here, this represents how much whales eat per day, and the D equals how many days. If it's 1 day, it's 4 times 1. If it's 120 days, it's 4 times 120, giving you 480 tons of food. That's why whales are so big. Okay, top of the next page. They're not always going to be story problems. Sometimes they're going to be really straightforward, as you're going to see in example 2. Okay, so if you have to turn the page, do so. If you're still on the same sheet of paper, that's cool. Some of you write big, some of you write small. Your letters or your notes are personalized to you. You're writing for yourself and for me when I have to grade it. Evaluate the expression when x is equal to 10. Sorry, I forgot to write that. Evaluate when x is equal to 10 and y is equal to 4. So what they're telling you is they've predetermined a value that they want you to use when you start to evaluate. And letter A has x plus y, right? They want us to evaluate x plus y. X is 10. Y is 4. How do I know that? Because they told me. It's like Jesus loves me, this I know. Because the Bible tells me so? Okay, well, because the math book tells me so. You know, bad joke, guys, I'm hot. My good ones are all gone right now. Once I cool off, I'll be better. Okay, so that was the answer, 14. Any questions on how I got this? Plugged in this, used the operator, which in this case is add, came up with an answer. Ben, are you square? How about you, Mr. Criddle? You all right? You melting? Okay, Mason, good? Okay, let's move on, friends. Letter B. What if they say to you this? Well, I don't know if you remember, but on the previous page, I tried to share with you that when items in a letter number, or two letters are placed side by side, that means multiply. You are going to see the X multiplication symbol less and less, Emmylou. So, X equals what, guys? Anybody know? Go ahead, Ryan.
10.
He's right. Anybody know what Y equals? Go ahead, Ethan.
4.
He's right. Now, I'm just going to do that just so that I recognize this also means multiply. And you're going to see a lot of that stuff. The product is 40. Okay? Here's another example. And this one is for you guys to try. 2x minus y. Just like we just did in this one, this is saying 2 times whatever x is. X is still 10, so it's 2 times 10 minus y is still 4. I haven't told you differently. It becomes 20 because 2 times 10 is 20. Minus 4 because y is 4. Okay. Here's the original expression. Here's the plugins. X is 10. Why do I know that? Because I told you. Y is 4. Plug it in. Why do I know that? Because I told you. 20 minus 4 gives you your outcome of 16. Okay. Please look at the center of page 6. Math is not always written in numbers and symbols. Math is oftentimes written using a verbal model. This is nothing more difficult than a story problem, word problem. You might think that's extremely difficult, but it's not. Take a gander at this. 6 plus 2, shoot, I'm writing in cursive again, equals what? That's a verbal model. 6 plus 2 equals what? Anybody know? Sarah? She's right. Just because it's written using words does not mean it's any more difficult. Obviously, I know they get more complex. That being said, the middle of page 6 has boatloads of words that mean addition, subtraction, multiplication, and division. Do you guys see that under the blue? Take your finger and point to common words and phrases that indicate operations. I know I'm getting geeky up here. I promise you, you're going to have a word and you're going to be like, wait, what does that mean? Look at of. What does of mean, Eli? It's in the third column at the bottom. Yep. Half of 10. If you multiply 1/2 times 10, and it froze again. No, it did not. If you multiply 1/2 times 10, you would get 5. 1/2 of 10. Example 3, and we're almost done, folks. Example 3 at the bottom. Baseball. Chris Matherly, read me the baseball story starting with You Plan 2. Wow, a little bit tricky, but please, please, please don't worry. Okay? Remember, we want to find out some teams, right? How many teams we can get? Well, the amount of teams we can get is based upon the number of players available, right? Players in the league. The number of players available divided by dudes in team. Okay? How many people are on the court in a basketball game? 5? 5 on each team? Okay. So in this scenario, we know we have 120 players divided by the amount of players we put in each team. Now you might say we only need 9 guys. Is that right? Okay, but what if one guy gets hurt? Then you're out of luck. So maybe this particular organizer is going to use 15 guys per team, or maybe 20, because there's just not enough coaches. This here indicates how he would establish the count of teams. Okay? It doesn't give you an answer. All it tells you is the phrase you would use to come up with the answer. 120 is players available divided by how many dudes you put on each team. Let's quickly come up with an action plan of what if I want 20 kids per team? Can I come up with a real answer to indicate how many teams at this point? By plugging in? Sure I can. How many players available? 120. How do I know that? Because they told me. We've decided that since we only have a handful of coaches, we're going to put 20 kids per team. 120 divided by 20. How many teams will I get, Leah? Somebody said 6. Very good. 6. And again, this is my scenario. This isn't something you're going to find in your book. I just wanted you to see a real-world application. Let's just say I had 10 coaches. Let's just say I had 10 coaches. I could find out how to divide it up that way as well. Okay, I won't get any further into that though. Any questions on the baseball scenario? Algebra is really just using what you have to solve problems, okay? The guy who actually designed it was from the Middle East, and his name is like Algebra, blah, 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 blah. And they shortened it, and they used it to assign his name to this study of mathematics. Okay, useless fact number 1 for the year. Extra credit for the person who counts them and knows how many useless facts I've given you.